Good morning all. I am Snehal Gurani. Today we are learning another MATLAB simulation with the help of datasheet. So first of all, today we are going to take a datasheet of Adani company. So this is the datasheet. It has 5 bus bar, multicrystalline means polycrystalline solar PV modules, 1000 volt series. The numbering is ASP7, AAA means it is ranging from 300 to 330. 72 cells are connected, and this is the value of watt peak ranging from 300 to 330 watt peaks. These are some highlights or specifications or required company specifications. It can work superiorly with the help of at the low light irradiation, and the performance is comparable and it is good for 200 watt meter square value. These are some benchmark modules. So tier 1 benchmark modules and 3-star rating is available. Reduces installation cost by 2%, transportation cost by 2%, land cost by 2%, and BOS cost by 2%. These are some comparative analysis and VI characteristic graphs for 320 watt peak modules. Technical specification or datasheet that we have to enter for our system. We are considering the last one, 330 watt peak value. So for which VMPP is 37.71, IMPP is 8.75, VOC is 46.4, and ISC is 9.24 amperes. Module efficiency is 16.97% as per the datasheet. Other parameters at NOCT, physical parameters, coefficients of temperature, current, voltage and powers, length, width data required for the calculation purposes, weight of the module, protection classes, 72 number of total cell, and one cell is having size of 156.75 mm in length and in width. So these are some specifications that we need to taken care while we are simulating for this. This is a similar data sheet available directly on net, so I have just opened up. So here it is, PRC type cell types are there, cell dimensions are given, data sheet, efficiency is mentioned, and all the parameters have calculated. So we have to consider those parameters. Operating range of this panel is minus 40 degrees Celsius to 85 degrees Celsius. So the temperature between minus 40 to 85 is suitable for the operation, and this panel can work smoothly. So now 156.75 mm cells has to be taken care, and number of cells are 72. So here for the calculation purpose, model of PV cell, and these are some equations which are required for the simulation purposes for mathematical calculations. No need to remember them right now, because as and when required I will explain them and we can use this for the calculation purpose. So this is the data sheet or the backward side connected sticker information of the panel. So it is manufactured by Adani at Mundra Solar PV Limited, SEZ units. This is the address of the location, email IDs and contact list. Made in India, so it is completely a Swadeshi module which is used for the installation purpose in domestic levels, and the subsidy is given to the consumer only if they are using Swadeshi panels at their location for the installation purpose. The module is ASP7 330, so 330 is the watt peak value. These are some value of voltages and current as per the data sheet, so they have mentioned. Now I have installed 3.3 kilowatt solar at my home, so 5 modules in series and 2 in parallel. So maximum 5 modules are connected in series, so the current is connected in all 5 modules connected in series, and there are 2 rows, so current is double, so IMPP into 2, so current rating is available, and VMPP in series voltage increases. So 37.75 into 5 times the value of voltages. So this is the value of current and this is the value of voltage. So 17.54 is the value of current and 188.75 is the value of voltage. Combinedly it is giving us 3.310 kilowatts. So 3.3 kilowatt power plant capacity is assured. 5 bus bar means 6 cells in width, total 72 number of cells, so 12 cells in lengthwise. So total length effectively is 12 into length of this, so 1.881 meter, and width wise 0.1657 into 6, so it is like this. Extra length on either side is for the purpose of safety margin on either side is 0.0585 meter on both the sides on length, and on width 0.03475 meter. These are some safety margins after the cells. Now calculate the power of this. So first of all, input power is this 1 kilowatt per meter square is the value of standard insolation. Number of cells are 72 and cell area is 0.15675. So total number of power available is 1.76 into 7690 kilowatt. So cell efficiency can be calculated with the help of this power rating. So it is 18.7141%. Now module efficiency is 330 divided by this, so we can find out is 16.35% is the module efficiency, and data sheet has mentioned 16.97%, which is relevantly nearer. Again similarly we can find out that module efficiency is lower than the cell efficiency. Basic calculation for this are, these are some constant or coefficient of current, voltage and power. So ISC at 25 degrees Celsius is 9.65 amperes mentioned. VOC at 25 degrees Celsius is 45.20 volts. P maximum at 25 degrees Celsius is 331.29 watt peak. So what is the value of current at 40 degrees Celsius? So ISC at 40 degrees Celsius is equals to ISC at 25 degrees Celsius into 1 plus coefficient alpha I into delta T divided by 100. So this is the value of current after 40 degrees Celsius. So you can visualize this, the current increases from 25 degree to 40 degrees. Similarly for voltage, VOC at 40 degrees Celsius and VOC is 25 degrees Celsius are if you want to calculate VOC at 40 degrees Celsius, so 45.20 at 25 degrees Celsius and 1 plus coefficient of voltage into delta T divided by 100, so we can get the value is 43.0982. It is reducing. So as and when the temperature increases, voltage decreases, current increases, temperature increases likewise. So this is the proven case. As and when the temperature increases, current increases but voltage reduces, so ultimately power reduces. In case of lower temperature, current reduces, voltage increases, ultimately power is the product of voltage and current, so power again reduces. So this is some value of power at 40 degrees Celsius is 311.4126 watt peak with the help of this calculation. Again one important term that we have to calculate is fill factor. Fill factor is calculated with the help of VMP, IMP, VOC and ISC data. So it is 331.0675 divided by 436.18, so it is 75.90% as per the data sheet. Yes, as per the data sheet. If you want to find out the value of fill factor if mentioned, here is it mentioned or not? Here it is not mentioned. Fill factor values, yes, module efficiency is mentioned but fill factor is not mentioned. If not mentioned, we can calculate the same. Let me check once whether fill factor details are available or not. No, it is not available, but you can utilize this formula for the calculation of the fill factor. So this is how you can calculate the fill factor. Fill factor is a measure of quality of the solar cell. means it is calculated by comparing the maximum power to the theoretically power that would be available at the output terminal, both during open circuit voltage and with the help of short circuit current. So the fill factor is commonly termed or abbreviated as FF and is defined as the ratio of maximum power from the solar cell to the product of ideal VOCA into ISC. It is generally termed as the figure of merit of PV cell, which gives the indication how good your or how bad is your PV cell. Higher the value of fill factor shows that your PV cell is better. For multicrystalline material it is lower, but for monocrystalline material the value of fill factor is improved. One of the most important factor for the comparison of different cells is fill factor. This is the inverter that we have used. So the MPPT input voltage range is 100 to 490 volts DC, and the available voltage with this configuration at our house, it is like 188.75 volts, which is in the range of this value prescribed in the inverter itself. So it will effectively use this voltage and convert the power into usable form and insert or inject in the grid. These are some value of effect of temperature on PV cell. If temperature increases, current increases but voltage decreases. Again, temperature reduces, current reduces but voltage increases. So on x-axis voltage increases with decrease in temperature, and on y-axis current increases with increase in temperature. So this is typically VI curve for a solar cell. So from the graph we can understand this. The short circuit current increases with temperature rise. So the graph or the point moves on upward direction, or with increment in the temperature moves in positive y direction. Whereas in case of increase in temperature, for VOC the value reduces. So the point moves on x-axis on left hand side. So this will reduces the value of voltage. From this we can find out the value of series resistance. Shunt resistor can be calculated for this to move the characteristics from IMP to ISC and from VMP to VOC. IMP to ISC is on y-axis, whereas VOC to VMP is on x-axis. So this is how you can use this graph for the study purpose or analysis purpose. Now for simulation purpose, let me open first this module. So let me name it as, I have used direct previous simulation, so it is Adani ASP-7-330 module I am using right now. So the parameters which I am using is 1 or 1 in series right now. Parameters can be found out from this 37.71. Module per cells are 72. Open circuit voltage is 46.4 volt. Here it is 46.4 volt. Short circuit current is 9.24 amperes. VMP is 37.71. IMP is 8.75. Voltage degradation or voltage percentage, the coefficient value of voltage is here it is, voltage is minus 0.31. So minus 0.31, and for current it is 0.069. so it is for current it is 0.069. apply and OK. I am now just simply Control C Control V copying it. Let me connect this to IR and this to T. Yes. Now positive to connected with negative, again this positive to this negative, positive to negative, and positive to negative. So here I have used 5 this terminals. This is no issues. Resistance. Okay. So let me run this first. So this is the value of current, power, and this is the value of voltage in series connection. You can check this. Current is 9.2 and current voltage is 140.6 volts. If we want to check the parameter of whole plant, you can simply use this So this is 9.2 amperes current and 140.5 ampere is the value of voltages. I have just stopped it right now for this purpose. You can use this module for your check, and I am just saving it right now for future use. Save as Adani series modules. Save. Yes. If you require this simple module connection, no need to add all this again and again. Just simply connect this to a negative terminals. Yes. Like this. Yes. 1025. You can directly go to this. Number of parallel strings are 2 and series modules connected are 5. Apply this. Okay, this will give you a complete function of 10 and see this voltage and current. So here that we have calculated current and voltages at our location is for the plant. Current is 17.54. 17 point. So I have to increase the value of current. So 5 ohms, the value of resistor. Run. So it is reducing the value of voltage. So increase the value of resistance. 15 ohms. Again run this. Yes, 13.77. So yes, it is 17.54. So I have to reduce the value of resistance. So 10. Apply. Okay. Run again. It is giving 18.01. So again increase 10.5. Apply. Okay. Let me run it again. 185.5 and 17.7, 17.54. So again just a small change in the value of resistance. 17.4, apply, okay, 17.7. so reduce the value of current here is 17.54, so 10.55, apply and okay, again run this, 17.5, okay, 10.60, apply, okay, run it, okay, 17.6. now a marginal change is required, we are just smoothing it again, okay, run this, 17.5, the value of the current, so 655, okay, run, okay, run it again. 17.55 is the current, value of the voltage is 187.7 and power is 3294. so 17.55 is the current, 188.75. let me smooth it for some more value, 75, apply and okay, let me run it again, oh increases, so 72, apply and okay, let me check the value again, 17.53, the value of current, and 17.54, okay, so I have to reduce it further, 10.71, apply and okay, yes, 17.54, 17.54 is the value of current, 187.8, this is the value of voltage, nearly 3294 is the power output, which is nearly 3.3 kilowatt. So with the help of this you can check this value of power of whole unit. I have simulated for 3.3 kilowatt plant. Here you can check the different temperature like 30, 25, 20, 10, 0 and plot the characteristics. So this is the value of effect of temperature. So this lower and lower, 0 degree Celsius, 10 degree, 25, 30 and 45 degree Celsius. These are some characteristics for implementation. And if you want to find out the value of different installation, so 1800, 600, 400, 200 and 100, plot this. Yes, so this is the value of characteristics, and the same can be compared with your data sheet. If you want to compare with the data sheet, let me show you the same. Yes, it is the data sheet. If graph is, yes, no graph is available. So here it is, the graph or characteristics. You can check this characteristic with MATLAB figure as well. So yes, here it is. You can compare this 1000 watt per meter square, 15, 10, 5 and 0. So this is are the values of insolation and the power output produced by the relay, by the module. So this is how you can cross verify with the data sheet is itself. So okay, so this is for the today's simulation study or simulation work. Hope you have enjoyed it.